Hi all, in this video we will learn how to build a small network using Cisco Packet Tracer, and we will also learn about different networking concepts like what is an IP address, what is a MAC address, how the routing work, and how the DNS resolution work. So in this video, it will be a little bit detailed video. We will build a small network and we will also try to communicate out of the network. And yeah, so just watch this video till the end if you really want to develop your basic skills, how to practice your networking or how to learn different, how to build a small network in a building or how to troubleshoot this different networking issues. So first of all, we will get a PC and we will get one LAN switch. Okay, and then we will get one of those, let's say first stick to the one PC and one LAN switch. So imagine that you are in this building, okay, and you have about 20 or 10 or 15 different PCs. I'm not going to drag all those 10, 20 PCs, so I'm just going to drag, let's say, 3 PCs here, right? So this is your LAN switch, and these are your 3 computers at the moment, right? So what we need to do is we need to connect these, first of all, these to the switch. Okay, so this is connected to port FA01, FA02, FA03. Right, okay. So this is our 3 computers network. But at the moment, they cannot communicate with each other because they don't have an IP address assigned to them. So any devices to talk to on the network, they need to be assigned a network IP address. But how are we going to assign the IP address to them? So first of all, we need to dedicate a, a network for that. We need to assign a network number or, where we're gonna get the IP addresses for that network. So let's say, for example, we have here a network 192.168.10.0/24. Means we can assign any of these IP addresses to these PCs. So let's say the first PC has 192.168.10.1, and the second PC has 192.168.10.2. And the third PC has an IP address 192.168.10.3. So these 3 PCs have been assigned these IP addresses, but I've just written them here. This is our main network in this building. And in order to assign these IP addresses to these computers, we need to click on them. And then we need to go to desktop and then need to go to IP address. And the first PC IP address is 192.168.10.1, and the subnet mask, as you said, is 255.255.255. We are not setting up any gateway yet. We will set up this later when we will discuss the routing part, right? And then I'm just going to close it. I'm going to go to the similarly network 2, and I'm going to configure these IP addresses 192.168.10.2. 255.255. I'm not considering, as I said, gateway. And the third PC, let's say this 192.168.10.3. Sorry, 3. Okay, so these 3 IP addresses have been now assigned. If I go to the switch now, because this is a layer 2 device, we don't configure any IP addressing on it, on these ports, because they learn the MAC addresses. They work on the source and destination MAC addresses. They will build a source and destination MAC table in there. So if I go to here first, show MAC address, MAC address table. So right now, as you can see, this has learned the MAC addresses of 3 PCs on 3 different ports, right? FA01, FA03, FA02. So if you want to see the MAC address of this, let's say FA001, FA01, it learned from this. So if you go to this PC and IP address configuration, as you can see, the link IP address here is ending on 681B, 681B. So if you go back to the switch, 681B is here. So FA01. So this has learned the MAC address. The switch has learned the MAC address of 681B from port FA01, this PC, right? So now if I want to ping from 192.168.10.1 to 192.168.10.3, because they are on the same network, so we no need to actually what it's called configure the gateway, or because they are on the same LAN or same network, right? So if I just going to start the CLI for this PC, desktop terminal, sorry, desktop command prompt, right? So if I want to ping the PC number 3, ping 192.168.10.3. So as you can say, this can ping on the PC number 3. So similarly, you can connect as many PCs as you want on the switch, depending on the number of the ports on the switch, to the same network, and you can communicate between these PCs. But let's imagine if you have another network or another building somewhere, somewhere in a different location, or even in the same building or same location, but that is in a different network. So how are you going to communicate between them? So we're going to create another network. Let's say the other network is right. I need another switch here. I'm going to build it on this side. And I need, let's say, 3 more PCs here. Just 1, 2, and 3, right? Okay. And then I will need so imagine that this is another network, right? This is somewhere far away or remote network or whatever. Okay, so we're going to connect this network again, similarly like we did previously. So this is going to be here. This is going to be here. This is going to be here, right? And now we're going to just make it look like just one network here, for example. Okay. And imagine that this is another network. So we call it, for example, 172.16.10.0/24. Okay, so this is another network where we have /24 subnet, and we have the last octet is reserved for the host bits. Okay, so we will assign the individual IP addresses to these PCs. Let's say the first PC has 172.16.10.1, and the second PC has 172.16.10.2, and the third PC has 172.16.10.3. Okay, so now this is another network, right? So similarly, we will assign these IP addresses to these computers. Okay, so I'll go to the configuration tab, IP address configuration 172.16.10.1, and the subnet mask will be this 255. We are not setting up gateway yet. We will go into the gateways again. Okay, so let's close that. Similarly, we will set up the IP address on this one, 172.16.10.2, and I'm just going to close it. And on the third PC, I'm going to set up the same way, 172.16.10.3, right? So now we have set it up the three IP addresses on these three PCs on these computers, right? Okay. So again, we will verify the communication at the LAN level, and before that, we need to go to the command prompt, and we will ping 172.16.10.3, right? As you can see, from .1 to .3 we can ping without setting up the gateway because they are on the same LAN and we don't need a gateway. We're not communicating outside our network. Similarly, we were able to ping here. Now imagine if you want to ping from 172.16.10.1 to one of these PCs, 192.168.10.1. We don't have any connection between them. So we first of all we need to build a connection. And because this is outside the network, because this is not in our network, so this IP address network number is 172.16.10 and this is 192.168.10, right? So these are two different networks. And we cannot ping if you try to ping, let's say, just to show you, if I go back to this PC again and command prompt, if I try to ping 192 ping 192.168.10.1, for example. So we don't have any response back from them. For obvious reason, we don't have any connectivity between them. So let's build a connectivity now between these two different networks. Okay, so for that purpose, we need a router. In order to communicate between two different networks, we always need a routing device, right, which can route between two different networks. At the same level, in the same network, we need a switching part. Switch will learn the MAC addresses, and based on the source MAC address and destination MAC address, it will forward the frame to different PCs. But in order to route the packet between different networks, we always need a router, right? So in order to connect that router, let's say if we connect here, we give a connection from here, and then we connect this router to here as well, right? So now we have a connection between these two networks, right? Okay. But will it still work? No, we need to configure the settings on this interface and on this interface, right? As you can see, this is orange at the moment or red at the moment. So it means the link is down. So why the link is down? So first of all, these ports, although they are connected, but we need to unshut them. So in order to unshut these ports, we will go to the command line of this Cisco router, okay? So we will go to enable config T, show, let's see, show IP interface brief. Oh, sorry. We need to do show IP interface brief, right? So we have three links which are connected, 00. I'm sorry, two links which are administratively down, unassigned, right? So they all are unassigned, right? 000103. So first we're going to do is we're going to unshut these interfaces and you will see the link state has been changed, right? Config T interface gigabit ethernet 0/0, okay? And we're going to do no shut, sorry, no shut. As soon as you hit the command no shut, you will see this has started becoming green, right? This will become an active link at layer 2 level, right? Similarly, we will go to the second interface, config T interface gigabit ethernet 0/1, and we will do no shut. So as soon as you hit the no shut, as you can see, this link has started coming up. Now the next thing is we need to define this IP addresses to these interfaces, right? So the IP address has to be on this interface because belongs to is part of this network, right? I'm gonna extend that circle to probably yeah. I will delete that circle first, and we'll redraw it. We'll redraw it, and I'm gonna do the same here. Okay, so now I'm just for clarity purpose. This is our first network, okay? And similarly, this is our second network, right? I'm just doing it on a very basic level so you can understand, right? So I'm going to assign the same range IP addresses here, 192.168.10. Let's say 100, we assign /24. So it's in the same network, 10.10, same network, right? So 100 different IP address. And in this case, I'm going to assign 172.16.10.100/24, right? Okay. So now we're going to configure these interfaces, IP addresses on this router interfaces. Okay. So I'm going back to the CLI command of this here. So first we will configure config t interface gigabit ethernet 0/0, right? IP address 192.168.10.100, and then we have to define the subnet mask 255.255.255.0, right? Okay, similarly we will exit from here, and then we will go to config t interface gigabit ethernet 0/1, and then we will assign the IP address 192.168.10.100, and the subnet mask is 255.255.255.0, right? Okay, so now if you do show IP interface brief, so you can see we have assigned these IP addresses to these interfaces. Now, in these PCs, we can still ping. If I go to this PC now, can we ping .100? Yes, we can ping .100. That's the first check. Okay, and in terms of routing, because in order to get to the second network, this is going to be our default gateway now. .100, this interface. As you can see, in order to reach any of these pieces, every packet has to go. I can explain a little bit more in detail on this because this is going to be very important to understand, right? So this is a very important concept about routing actually. So in order to, let's say, if this PC want to send a packet from this PC to over here, this PC, so the packet will be, the source IP address in this case will be, source will be 192.168.10.1, and at the destination would be 172.16.10.1. Now this packet with the source and this destination, because this is a different network, destination 172, right? So what it will do is, this PC will know this destination is not on the same network. So what it will do is, by default, it will send all those packets which are not in the same network to its default gateway, which is this one, right? And on the router, once this router will receive this packet, it will check in its routing table where is the destination needs to be going, because on this side of this router, this is another local network. This is a local, this destination is a local network. So it will simply forward the packet to this direction, right? Okay. So yeah, because this network is local to the router, is attached to this router. If it was, let's say, there were two more routers here or three more routers, this destination was here somewhere, right? Then there was going to be a different scenario, which we will discuss later, maybe in some other video. Okay, how those packets will be routed in these three different routers, right? Now, in this case, let's try to ping this. Let's try to define the gateway here first of all. If we go back to desktop and IP configuration now. Now the default gateway in this case is 192.168.10.100, right? Okay, so similarly on this one, okay, 192.168.10.100, right? Okay, and on this one, 192.168.10.100, right? And similarly on these PCs, these are the different networks, so we will define those gateways. So in this case, the gateway IP address is 172.16, Okay, so I'm just going to close that. I'm going to open it. IP address configuration, default gateway is 172.16.10.100. Okay, and then in this way as well. 172.16.10.100, right? Okay. So now we have defined the gateways on all these PCs. So as you can see, previously we tried to ping. If I go back to command prompt, so we previously tried to ping 172.16. Sorry, 192.168.10.1. So can we ping it now? Oh, here we go. So now we can ping any of those PCs from here to here, from here to here. So because this is now a routing has been involved in this, we have created a route, involved a router between these two networks. So this is the way you can build a small network with, and communicate between those two different networks. And I think if I'm going to the details of further, like let's say DNS and IP routing and creating some IP routes in the router, this video is going to be very long. What I will do is I will create another video starting from the same thing where we have built this network for now, and we will learn in the other video about the DNS settings, ARP, what is ARP, what is IP, what are the IP routes, and how they are configured, right? So for that, you will have to follow my next video. Thank you very much. Please hit the like and subscribe button if you like my video. Thank you. Bye.